All right, hello everybody. We're talking about question 1 here on the homework assignment, factoring C-tree and box method. The first question talks about factoring, so let's remind us how that works. We have an A, a B, and a C value, and we take this C value here and break it down to come up with the combination of numbers that will get us the B value. So we take this 45 and write down all the factors of 45. So that's 1 and 45, 3 and 15, and 5 and 9. What we need to do is look at which combination of numbers can get us to a positive 4. Well, if I look at this 9 and the 5, if I make 9 positive and 5 negative, I know this combination will yield a positive 4. So what we need to do is then take this trinomial and write it as two binomials, x minus 5 and x plus 9. That's it. Nothing else that we need to do here. Now, if we take a look at number 3, number 3 has a little bit of a different situation going on, right? So we know that we have to use the box method here because our A value is a number bigger than 1, and that cannot be factored out. So I went ahead and did this problem already, but I want to highlight some things here. So what we did was I located that x was shared between all three terms here. So I factored out an x, I did the GCF, and then I rewrote the trinomial without the x term in every single term. So that looks like 7x squared minus the 22x plus the 16. Now I went ahead and did the box method here, which means that we take the very first term and write it inside of our very first box cell, and then we take the last term and write it in the last box cell. Now this is going to be extremely similar to the C-tree method. Instead of breaking down a 16, what we break down is 7 times 16. So we take the first term and the last term again, and multiply them to make a larger number. So that's what I did here. Took the 16 times the 7 and made a 142. 142 is a rather large number, so I got a little scared that I had to break it down. But I did it anyway. So I took the 142 and I broke it down to 1 and 142, and then 2 and 71. And I asked myself, which combination of numbers can get me to a negative 22? Well, there isn't. There is no combination of numbers. There's no more factors that can create 142. It's one of those weird big numbers that doesn't have a lot of numbers in common with it. So since there was no combination of numbers that could create a negative 22, this one is defined as not factorable. I believe this is the only question on the homework, but I could be incorrect. So let's look at a question where we actually do use the box method, number 4. So I recognize I have to use the box method here because my leading term again is not 1, it's 5. So I'll draw my box, fill in the information. First term goes in the first box cell, 5m squared. Last term, which is the 2, goes in the last cell. And I take those two numbers and I multiply them to get a larger number. 5 times 2 is 10. So I got to take 10 and break it down. 1 and 10, 2 and 5. Which combination of numbers can get me to 11? Oh, that one's easy. 1 and a 10. So 1m and a 10m. Now what we need to do is look at these columns and rows and figure out, okay, I need to do the GCF of each of these and figure out which combination will work. So we have 5 and 10, the greatest common factor is a 5. M squared and m, the greatest common factor is an m. Looking at this second one, the biggest thing that 1m and 2 have in common is a 1. So the first row here, 5m squared and a 1m. Biggest thing they have in common is an m. And the second row here, 10m and 2, the biggest thing they have in common is a 2. It's the biggest number that I can pull out between 10 and 2. So these are actually the binomial answers, 5m plus 1 and m plus 2. We don't need to do any solving. They simply tell us to just factor it out, and that's all we'll need to do. I hope this has been helpful. Please let me know if you have any questions, and have a great day.